Okay, in today's class, I thought of solving few problems which are actually based on this formula a square plus b square plus 2ab cos theta. Correct? Notice that you have two vectors, vector a and vector b. The angle between them is theta. Now the same theta is put here, right? Then what will be the resultant? You know, resultant will get it by completing the parallelogram, right? So based on this trigonometry and based on this logic itself, we try to find out the magnitude. So if you try to find out the magnitude using trigonometry, Pythagoras theorem, and everything, this is what we got, right? Thought of doing these problems, but there are cases where you may end up getting theta greater than 90 degrees. Okay, so then it will be really confusing. So I thought of showing you a animation where you can find out the trigonometric ratios for angles greater than 90 degrees, right? Now that person, he has explained in a very neat manner. Okay, now try to note down. Okay, better to draw the graphs whatever you are seeing in that particular video in your notes, fine, right? And one more thing, there he'll mention some units called as something called as radians. Okay, radians and gradients, fine. Now all of us know about degrees, right? Degrees. So the same degrees what we have seen in our protractor, right? So 90 degrees actually means perpendicular line. Okay, right? So 30 degrees. So usually we say 30 degrees, like that, fine. Now apart from degrees, we have two more methods to measure the angles. Okay, so those are radians and gradients, we'll say. Okay, degrees, radians and gradients. Okay, now all these three, they are actually the units. Okay, they are units of, or you can say units of measurement. Okay, they are the units of measurement of your angle. Okay, so we will use degrees, radians and gradients. Okay, so most of the time, okay, most of the times we'll be using the 1 and 2. Okay, so degrees is a unit of measuring angle, radians and gradients are also units of measuring angles. Okay, fine. So he'll mention these two words, don't get confused. Now what is the relation between degrees and radians? Okay, we'll see that, fine. So you will learn all these values of trigonometric functions for more than 90 degrees. Okay, so 180, 270, right? All those things you will be studying in mathematics, but before studying in mathematics, we actually need it in physics. Okay, so therefore watch this video. All right, so we'll solve problems in the next class based on this relation. Okay, based on this relation here. Okay, then we'll go to analytical method. Okay, problem solving using analytical method. Fine. All right. Okay.
In this tutorial, we're going to take a look at the graphs of the sine and cosine functions in degrees. There's a couple different ways, actually there's three I know of, to measure angles, sorry. Degrees is one, radians is another very common one, especially in getting into higher mathematics. And then there's also gradients too that I know of, but I have never ever seen it used. The difference between degrees and radians is in degrees, there's 360 degrees in a circle, so the definition of a degree is it's 1/360th of a circle. Gradients, there's 400 gradients in a circle. So a gradient is 1/400th of a circle. And actually the nice thing about gradients is in a quadrant, like to rotate from here to here, like a quarter of a circle, there's 90 degrees, but there would be 100 gradients. So actually, that's kind of nice in a way to be able to work with it instead of degrees, because our number system is base 10 instead of base, well, 60. But anyway, that's another point. So we're going to start filling in this table here, and I'm using multiples of 30. I could use other angles too. I mean, if I want to do like 0, 5, 10, 15, 20, 25, 30, I could do that. My blocks here, every block is actually 15 degrees. So that's 15, that would be 30. 45, that'd be 60. So we're actually graphing for every second one. So let's start filling out the table here. And again, make sure your your calculator is in degrees, not radians for this one. So the sine of 0 we'll start with. The sine of 0 is 0, so we're going to put a 0 there. And then I want to go 30 degrees next, so 30 is going to be 0.5. And then we're going to do 60, So now I'm going to round that to 0.87. So it's a little less than 0.9. If you round to 0.9, it's still going to be pretty close. You're still going to be see pretty much exactly what we want to see. So let's so 0 here, 0.5, and 0.87. Bring the calculator back. And then we want to do 90. So I'm just going to edit this, put 90. Sine of 90 is 1. And then we want to go to 120. And actually, if I don't close the bracket, the calculator is still going to evaluate that properly because it's programmed that way. I'm just going to be doing this. I'm just trying to show proper mathematical form. That's why I'm closing my brackets here. So sine of 1, so 90 is 1. This is going to be 0.866. The 150 is 0.5. And then let's do 180. Okay, so remember, that's going to be a 1 there. So back down to 0. Excuse me, I'm coughing here. So that's going to be 1, 0.87, 0.5, and we just did 0. Now we want to go to 210. 210. So the 210 is going to be negative 0.5, and then my 240 is next. So that'll be negative 0.87, and let's go to 270. Is down to negative 1. So that one's going to be negative 1. So negative 0.5, negative 0.87, negative 1 for those three. And then we'll do the last three. So I'm going to do 300 next. 300. So that's going to be negative 0.87. 330 is negative 0.5. And 360, you might guess, is back to 0. So negative 0.87, negative 0.5, 0. Now, I'm going to do the cosine table before I start graphing too, so I just want to complete the table. So, cos 0 is 1. So that's going to start with a 1 function value of 1 there. And let's do 30 next. So that's going to be 0.87. And then we'll do 60. That's going to be that's going to be 0.5. So 1, 0.87, and 0.5. 1, 0.87, and 0.5. Now we'll do 90. I'm just doing 3 at a time so you can see them all in the calculator at once. So there's the 90. And then we'll do 120 next. 1, 2, 0. Close my brackets because I want to show good mathematical form. And the 150. So this is going to be 0. This is going to be negative 0.5 here for the 120. And then this is going to be negative 0.87. And actually, I think I'll do the 150 here as well. So remember, the 90 is the 0. I guess you're still going to be able to see that anyway. Yeah. So that's the 0 for the 90. Negative 0.5. The 150 is negative 0.87. And I just did the 150 again, didn't I? Okay. Well, let's stop here and put in the numbers we just had. I did the 150 twice here. So, yeah. Let's change that to 180. There we go. So the 180 is going to be negative 1. Negative 1 there. And so now I want to go to 210. Whoops. 210. So this is going to be negative 0.87. And then the 240. So that's going to be negative 0.5. And the 270 is going to be 0. So negative 0.87, negative 0.5, and 0. And 3 more in the 300s. 300. So that one. 330. So that's going to be 0.87. And you might guess that 360 is back to 1. So 0.5, 0.87, and the 1. So now we're going to start graphing them. So 0, 0, so 0, 0 is here. So 30 degrees would go up to 0.5. So remember, that's 15, so that's 30. So we're actually every second block here. We're at 0.5, so we'll put a dot right there. And then above 60, which is here, we're up to 0.87. So just below the 0.9, so about right there. And then at 90 degrees, we're at 1. So above 90, we'll put a dot at 1. And then at 120, we're back down to 0.87. So it will be at the same height as that one. And then at the 150, okay, 150 be right here. We're at 0.5. Whoops, 150 right there. There we go, 0.5. And then 180s, we're at 0. And then at 210, so 210 will be here, or at negative 0.5, so that's going to be right there. 240, it's negative 0.87, so 240 be here, negative 0.87, so that's about right there. And at 270, we're at negative 1, so that'll be right there. So now at 300, 300 degrees, that's 270 right there, so 300 would be right here. We're at negative 0.87, that guy right there. And then at 330, we're at negative 0.5, so 330 would be here at negative 0.5. And at 360, we're at 0. So 360, the function value is 0 right there. So if we draw a smooth curve between these, that's what the sine function looks like. That's y equals sine x. Now let's do the cosine. Oh, I clicked and I got the first point. So at 0 degrees, it has a function value of 1. At 30, it's 0.87. So 30 degrees would here, it's 0.87, so that's about right there. And then at 60, it's 0.5. So 60 is at 0.5, so put a dot there. And at 90, it's down to 0. Right there. 120, it's at negative 0.5, so 120 would be here. So negative 0.5, we'll put a dot there. And at 150, it's negative 0.87, so that's 150. Negative 0.87 is about right there. And negative at 240, whoops, I skipped a couple. That's the one we just did. So at 180, it's at negative 1. So 180 would be negative 1 right there. And then at 210, so 210 would be right here. It's at the negative 0.87. That's that one right there. And we go to 240, it's at negative 0.5. So 240 will be right here. It's at negative 0.5. And then 270, it's at 0. So 270, it's at 0. 300, it's at 0.5. So 300 would be here. It's at 0.5. And then 330, it's 0.87. So that would be right about there. And then at 360, it's up to 1. So 360, it's at 1. And so if we draw a smooth curve between those, that's what the cosine function looks like. So you can see these are actually periodic functions, and there's a little something I want to do here just to show how they will keep replicating the same shape. So if I were to extend the table, let's say to 3 more multiples of 30, 390, 420, 450, and evaluate the trig functions for those. So if I did the sine of 390, and then I'll do 420, 420, and then I'll do 450. Okay, so 0.5 here, 0.87 here, 1 here. Notice it's duplicating the same kinds of values. And actually, so if we graph 390.5, so 390 would be here, that's a y value of 0.5. And then 420, which would be up here, it's up to 0.87, so that would be right there. And at 450, it's at 1, so 450 would be here, it's up at 1. And notice, so if we draw those together, see that's duplicating the same kind of shape we had here. So it is going to replicate the same pattern. Now if we do the same thing for the cosines, let's do actually, yeah, this is the simplest way to do it probably. I do replay this and I just change my sine to a cos. There we go. So there's my cos 390. And now I do cos 420. Right back there, 420. And then my 450. Just edit the 2 to a 5. So this is going to be 0.87. 420 gives us 0.5. 450 gives us 0, so that's where I'm going to get those function values from. And so we plot them, 390 is 0.87. So 390 is 0.87. The 420 gives us 0.5. So 420 gives us 0.5. And the 450 is back down to 0, which is going to be right there. And so you see it's just coming here and duplicating the same kind of shape it did there. So it's just going up, going down, going up, going down. So it's going to replicate for higher and higher angles exactly the same shape. Now, we're going to talk about the minimum, maximum value, the highest value, lowest value, the amplitude, I'll discuss that in a minute, and the period, the length of a cycle. So the minimum value is -1 for the sine graph. The lowest value it possibly gets here is at -1. And the maximum value is +1. It's +1 there. It would be +1 here. Okay. The amplitude is the distance from this middle line. It's called the axis. It's not actually an axis of symmetry. It's an axis in the middle. The amplitude is the distance between here and a max, or between this line and a min, which is 1 unit. So the amplitude is 1. And the period is the length of a cycle. See, this is one full period here. So from 0 to 360 is one full cycle. So that's called the length of the period. It's the length of one complete part of the graph before it starts to replicate itself again. So the period is 360 degrees, because after that, you see this part right here is duplicating what we did at the very beginning. Now the cos value's minimum is -1, the same, and has a maximum value of +1 here, here. Okay, so it has the same min and max, just at different places. Amplitude's still the same. The distance between the middle axis line and a maximum point, or the middle axis line and a minimum, is still 1. So the amplitude's still 1. And the length of a cycle is still 360. Okay, so that's one full cycle to there. And then this would be the start of another cycle. We're replicating what we did right here. So that's some of the characteristics of sine and cosine graphs. That's how we get the sinusoidal graphs. That's how you can actually graph them. And we could use, I didn't have to use this angle specifically, like if I took the sine of, let's say, 45 degrees, for example. Okay, I could have used other numbers. See, for the sine, okay, 45 degrees, see, that would be right here. See, that point right there is the 0.707 number. Okay, so I get other points on the graph. Like if I wanted to know the cosine, let's say of 105 degrees, I choose that because it's 15 after 90. See, that would be 105 degrees here. So the cosine value is negative. See, there's the negative 0.2588. Okay, that would be the function value right there. So I didn't have to use just exactly these values. I could use any angles. I just kind of spaced them out and did every 30 degrees, and you can get a really good idea what the graphs look like then. So that's the what the sine and cosine graphs look like in degrees. And that's the end of the tutorial.